Okay, so I'm going to hit you up with a question that I asked you the very first day of class. After we went through the syllabus, this is the first thing that I asked you. So at the top of the page, there are two mathematical objects there. They both look very similar, but they are different, and we do completely different things with those. Okay, the top mathematical object is an example of something we did in section 2. And then the bottom mathematical object right here, this is what we're going to do today. Does anyone remember the words for each of these things, the difference in these two? What was that? Which one? Okay, the second one is an object called an equation. The reason we know it's an equation, it's got the equal sign right there. And the reason I mention that is an equation, because of the equal sign, we can do some different things. We can treat it differently. We can solve this, which means we can find a value that creates a true statement. I'm making this distinction here because this is the most common mistake on this test coming up. The top thing that we've already dealt with, this is called, okay, again, this was the first day of class, but I know that's a long time ago. This is, I'm talking and writing, I'm not doing a very good job of either. This is called an expression. We don't solve expressions. There's no equal sign. What we can do is we can manipulate expressions and make them look different. And so just to, again, refresh our memory, this is what we did with this expression right here. We can actually perform the subtraction and write these two fractions as one fraction. Well, let's just run through that process real quick. What's the common denominator between these two fractions right here? The LCD between them is what? There you go. Not just the x, because each of these x's is attached to something else. The x minus 3 is one of the factors I need, and the other one is x plus 3. Great. And so then what we did, and so I'm just doing this for the expression. This is a review of what we've already done in this class. Okay, when there's no equal sign, I can't do anything but combine these two things. I'm merging them together. And so what I've got here is I'm going to write my least common denominator for each of these fractions. So I've got x minus 3 and x plus 3 for the first fraction. Then we're going to subtract, and I've got x minus 3 and x plus 3 for the second fraction. And then what did we do? Does anyone remember? Hopefully you remember, because you got a test on it next week. What did we do to change the numerators of each of these fractions? We multiplied by what's missing from the least common denominator. So for this first fraction, what's missing from this first denominator to get to the least common denominator right here? Yeah, the x plus 3. So we multiply here by x plus 3. Using a different color so that we distinguish what I am doing to this problem. And I'm going to distribute, and when we do that, we've got 2x plus 6. And then the second fraction, what's missing from this denominator to make it into the common denominator? Yeah, just the other thing, the x minus 3. So I'm going to multiply by that. And then I get 3x minus 9. And I made one other recommendation to you when we're subtracting. I like to distribute. If you have a different way to do this so that you remember to subtract everything, that's great. You're not always stuck with my way of doing things. I understand there's other good things, equivalent things you can do. So when I do this, though, I've got 2x and negative 3x, that's negative x. I've got 6 plus 9, that is 15, over x minus 3, x plus 3. The whole point of me reviewing that with you. Okay, well, first off, it's good to keep these things fresh in our mind. But the second reason is I just want to remind you what we do with an expression. We take two fractions and we wrote them in a new form, which is still a fraction. Okay, that's what we did. We are going to do something completely different when it's an equation, when there's an equal sign, and that's what today is about. Okay, when there's an equal sign, I think the problem becomes a little bit more straightforward with what we do with the common denominator and how we approach it. So here's my first example. I'm going to slide this down. We're going to solve the following rational equations. Once you've done one of these, the process is the same on all of them. we're just going to get used to doing this. So the way we're going to solve these rational equations is the way we solved equations with fractions way back on day one. We are going to clear the fractions. The way we clear the fractions, we take that least common denominator that we've been using for a couple classes, and we're just going to multiply every term by the least common denominator. Okay, so I'm going to write that instruction for you, just so that in case you, it takes you a little while before you get to your homework, you're going to multiply every term by the least common denominator. So we get a little more practice finding least common denominators. We use least common denominators in section 6.2 when we added and subtracted fractions. We used least common denominators last class when we simplified the complex fractions that were awful to look at. Now we're going to use it one more time to take this equation and get rid of the fractions so I don't have to look at them anymore. So on this equation right here, I've got 2 over x, I've got 3 over 2, I've got 7 over 2x. What's going to be the least common denominator for this? What factors do I need? A 2 and an x. Mentioned the instruction for this a couple classes ago, but in case you've forgotten, the way you find the least common denominator is you take one of every factor you see, and if there's powers, you take the highest power. Okay? One of every factor you see, if there's powers, you take the highest power. And so when the answer was given to me, you notice the factor 2 is included in the common denominator, the factor x is included in the common denominator. Great. Now we're ready to rumble. I'm going to multiply each of these fractions by 2x. So the first one here, 2x, I like to write it over 1 so that I remember I'm multiplying by my numerators by 2x. I got to squeeze this in right here, the 3 over 2, I'm going to multiply by 2x over 1, and then the 7 over 2x, I'm going to multiply by 2x over 1. Each of those 3 terms gets multiplied by 2x. Don't be shy in asking questions because you are going to do the identical thing in exercise 1 in just a minute. Okay, it's a very similar problem. Hopefully nice and straightforward, but if not, that's why you would ask me a question. Right, now we'll go through just what we've been doing. So in this first term, I'm multiplying 2x times 2 over x. What cancels in this first term? Yeah, the x does. This x cancels with that x right there. Goodbye. And I'm left with 2 times 2, or 4. Minus. The next one, I've got 3 over 2 times the 2x. What cancels when I multiply there? The 2 does. Boom. See you later. And so I have 3 times x. That's what's left over. And then equals. And then on the other side, I've got 7 over 2x times 2x. What cancels when I multiply here? Both of them do. The 2 and the x. The 2 and the x. Goodbye. And I'm left with just 7. So you see that we took an equation that looked kind of ugly and complicated. The fractions, we hate them. I don't blame you. They sometimes mess up our lives a little bit, and we've created this kind of much simpler to look at equation right here. This is what we did day 1 when we first met each other. So I'm just going to finish this up. I'm hoping you know the steps from here. I'm going to subtract the 4 from both sides, and I get negative 3x is equal to 7 minus 4, or 3. I'm going to divide both sides by negative 3, and I get x is equal to 3 divided by negative 3 is negative 1. Great. I'm going to write that as a solution set, the set containing negative 1, and I'm done with the problem. All right, so the big step, the new step, the thing that we have to practice, and we're going to do that, we got a bunch of problems here, is clearing those fractions. Once we clear the fractions, you're going to end up with something familiar. So exercise 1, right next door. Go ahead and do the same thing. Actually, let's do this in 2 steps. Take 20 seconds, write down what you think the common denominator is for exercise 1. What's the LCD? All right, so propose to me what you think the common denominator is between 3x, 4x, and 3. Okay, I'm going to go with the x, but if I do just 3 and x, I got to account for the 4. What's the common multiple between 3 and 4? 12. Yes, so we need to take that into account. 12. One of each factor. Okay, 3 and 4 don't share any factors, so one of every factor you see. So that's the 3 and the 4 and the x. So 3 and 4 is 12, 12x. Now that you have the common denominator, go ahead and clear the fractions and then solve the little equation that you'll get at the end. All right, let's run through this because then exercise 2 is also going to be pretty similar. So you're going to get another opportunity to run through this and correct any mistakes, ask any questions you need to. I understand this is a difficult thing. Okay, I want you to be able to do this. This is going to repeat itself when you take college algebra, no matter who you take for it. This is going to be a repeat thing, and we're gonna go through it a lot quicker. But we're gonna remind you, so you're gonna see this again. It becomes solving rational equations becomes important the further up you go. When you get to pre-calculus and calculus, it's a very good skill. Okay, so here we go. I've got 12x times 1 over 3x. So when I cancel here, what is left when I do all of my canceling between 12x and 3x? 4, yeah. The x's cancel, great. And then 3 goes into 12 and leaves 4. And then that 4 times the 1 that's there leaves me 4. So not too super interesting. The next one, I've got 3 over 4x times 12x over 1. When I go ahead and cancel and I multiply what's left over, what do we get here for this term? Okay, yeah. X's cancel. 4 goes into 12 and leaves 3. And then you take that 3 times the 3 that was already there, and that's 9. And then on the other side of the equation, I've got 1 over 3 times 12x over 1. What happens there? Perfect. Excellent job. 3 goes into 12 and leaves 4. There's nothing to cancel that x out, so I have 4x. Okay, so all I have to do on this one is I got to collect those like terms on the left. Then we're going to divide, and we'll be at our answer. Okay, so 4 minus 9 is -5. That's what my calculator would tell me. I'm going to divide both sides by that 4, and I get that my x value is -5 over 4. Nothing else to do there. If you write that as -1.25, that's delightful, but I'm just going to leave it here and be done with the problem. Yeah, I don't want to rush through this. I want to address any issues you think you have. Any questions about either of those problems so far? We're taking something we've done for a couple sections, finding common denominators, so we get to practice that. The new thing is clearing the fractions on the equation, and then it's review of something we've done before, solving an equation. Okay, so there's two things we've done before, one brand new thing. Try it again on exercise 2. Take 20 seconds, try to determine what you think the common denominator between 20 and x and 4x is going to be. All right, what do you think the least common denominator is between those three things? Yes, it's going to be 20x for sure. 4 is part of 20. Okay, so that's why it doesn't need to be 80. You could use 80 if you want to just go straight forward and multiply 20 and 4 and 80. That's not the least common denominator, but it is a common denominator. It'll work. You'll get to the right answer eventually. But 4 is part of 20, so I don't need to re-include it. I need the x. So there you go. 20x is the common denominator. Whatever you multiply by should get all these denominators to cancel. So if you wrote down something like 4x, okay, because you saw the 4, the problem with 4x, I'm just going to bring a clean piece of paper. You don't need to write this down at all. If you had proposed that the common denominator was 4x, well, look what happens when I multiply 4x times 20. The 4 goes into 20, but I still have something in the denominator. So that's how I know that I need to go back to the drawing board and recalculate my common denominator, because I should have no denominators left when I multiply. So that's why 20x is going to be the thing. So now go ahead and finish that problem. Multiply each of those terms by 20x. All right, so term by term, check your work with my work. If we differ, if you don't understand what's going on, that's a great opportunity for a question. So the first one, 3 over 20 times 20x, I'm going to cancel the 20s. And so what's left is this negative 3 times x. So negative 3x, that's my first term when I've canceled everything, plus the second one, the x's are going to cancel. And I have 2 times 20, that's going to be 40 equals. On the other side, the x's cancel, and then 4 goes into 25 times, and so 5 times 5 is 25. And there we go. I have cleared the fractions. I've made a much easier equation to look at. And so now I'm going to finish this problem. I'm going to subtract 40. That's the first step. And I get negative 3x is 25 minus 40. My calculator tells me that's negative 15. And then divide. And x is equal to 5. There we go. I'm going to write that in some squigglies. And I'm done. Solution set. Question? All right, the next one, exercise 3, the common denominator is a lot simpler on this one. I'm just going to give you a heads up. When you clear the fractions, you're going to end up with a quadratic, meaning you're going to have to factor like we were doing in the last unit. Okay, so give this one a try. You don't have to tell me what the common denominator is. I think this one's, it's kind of apparent. Can give you a couple minutes to work through. So what's the common denominator on this problem? P. It's the only denominator, for sure. So P. So I'm going to multiply each of the 3 terms here by P. So the first term, I know the first term's not a fraction, but you have to multiply every term by that common denominator so that you don't accidentally change the equation. So then on the other side, the negative 8 needs to also be multiplied by the P. All right, so here we go. The first term, P times P, that gives me P squared plus the second term, the P's cancel, because that's why I'm multiplying, is to get rid of that denominator, so I don't have to see it anymore. So 15, and then equals negative 8 times P is negative 8P. Now, this, we get to review a little bit. I know that sometimes our knowledge fades as we move away from a unit. I've got a quadratic equation. That's what this exponent means. It's a squared. So what do I have to do first in order to solve this? I got to add the 8P. It has to be equal to 0. No choice there. Okay, so I've got to add the 8P over, so I'll do that. And so here's my equation. I've got P squared plus 8P plus 15 equals 0. This is an unfoiling problem because I've got a 1 in front of the P squared. There's no number there, so that's the less complicated of the 2 situations for factoring. So P squared is P times P. What are my signs? What do they have to be here? They have to both be positive. The 15, remember, tells me they got to be the same. That's my lasts. And then since the 8 is positive, that tells me both positive. And then there are two factors of 15 that are going to add to 8. 5 and 3. Just going to slide this over here to the left a little bit, so I have a little more space. So now my two factors, I've got p plus 3 equals 0. I'm just going to slide down a little bit, p plus 5 equals 0. When I subtract 3, I get p equals -3. There's my first solution. When I subtract 5, I've got p equals -5. There's my second. So my solution set this time actually has two values in it. Double the fun. There we go. All right, we have two more problems where we've got monomials in the denominator. It's pretty straightforward. We're gonna keep trucking along. You've got a question, don't be shy. No reason not to ask it. Exercise 4, same thing. Let's take 30 seconds, figure out what the common denominator is. So you have to figure out what the multiple between 3 and 5 and 45 is going to be. You need to employ the listing method. Go for it. I think we'll all agree here in my common denominator, I need an x because I see that factor. The question is, what is the number in front of the x? So who can tell me what the common multiple between 3 and 5 and 45 is? It's just 45. Yeah, it's 45. Great job. So now take 45x, that's the common denominator, multiply that by each of the 3. From there, it should be a pretty straightforward problem. It's just another opportunity to practice clearing these fractions so we get nice and good at this. Right, so the first term, the x's are going to cancel, that's for sure. And then the 3 is going to go into 45. Your calculator can tell you that's going to be 15. Don't be afraid to use your calculator. Okay, it's all good. That's a tool. So 15 times 2, that leaves me 30 on that side of the equation. The next term, the x's again cancel, and then 5 goes into 45. My calculator will tell me that's 9. 45 divided by 5 is 9. So then 6 times 9 is 54. That's what that term is going to be. plus, and then the last one, the 45s cancel. And so then what's left is 8 times the x, and so 8x. There are my 3 terms. I no longer have fractions, so I can rejoice and be happy about that. And I'm going to finish this problem by subtracting the 54 from both sides. My calculator will tell me that 30 minus 54 is negative 24. And then I've got 8x. And when I divide by 8, once we get rid of those fractions, it's a much more tame problem than it starts to be. And so we get the x value that will create a true statement. My solution is negative 3. All right, one more problem with monomials in the bottom. Then we're going to flip the page and we're going to look at the other situation that can happen when you're dealing with rational equations. So last one, common denominator, and then clear the fractions. What's the least common denominator you're using? Yep, 4 and an x. That's one of every factor that I see. Okay, keep working. Great. All right, the first one, the 4s are going to cancel. So I've got x times x. So again, I have a quadratic. I've got x squared here. So we're going to have to do a little factoring in a minute. Minus the next one, the 4s cancel and the x's cancel. So I'm just left with that 21. Then on the other side of the equal sign, the negative 1 times 4x is negative 4x. So again, once those fractions are gone, this looks a little better. It's a quadratic just like the one right above it. So I'm going to bring the 4x over. We always have to have this equal to 0 so that I can factor. So x squared plus 4x minus 21 equals 0. That's my quadratic equation. Slide this up a little bit so we can see. I'm going to unfoil this. There's a 1 in front of the x squared, so x and x. All right, on this one, just to refresh our memories, what are the signs we're going to use here? Yep, this is a negative 21. That tells me to use one of each, positive and negative, or negative and positive. The order is unimportant. Now I have to pick my factors. What are the factors of 21 that are 4 apart? Yep, great job. There's my 2 factors. The rest of this, just going to set those 2 factors equal to 0. I'm going to subtract 7. My first solution is negative 7. My second solution is positive 3. That's my solution set. And we're done with that problem. Those are the two numbers that if I use them, will create a true statement in what I started with. Okay. So the process when we flip the page is going to be the same. We have one other thing we have to think about. Okay, I didn't want to lump it on you all at once. I wanted to talk about and get some experience of solving these equations. But these last problems are all going to work the same as what we just did. So example 2, first thing I have to do, like we just did, is I have to figure out what the least common denominator is. Before I do that, there's one of those denominators that I can factor. Which one of the denominators, the first, the second, or the third, is the one that I can factor? The third, the x squared minus 9. So I'm just going to factor it right underneath just to save a little space here. X squared minus 9, difference of squares. We factored a whole bunch of those in the last unit. So x and x, 9 is 3 and 3, plus 1 minus the other. That's my difference of squares. And so now what I want you to do, take 10 seconds. I want you to write down what's the common denominator there. What's one of every factor you see? Write it down. Let's see how you did. And what's the common denominator we're going to use on this problem? Yeah, x minus 3 and x plus 3. Great job. One of each. All right, so what I'm going to do here is I'm gonna squeeze in an x minus 3 and an x plus 3 times each of the fractions. So bear with me here. So x minus 3, x plus 3, that's going to be times the first fraction. Then I've got x minus 3, x plus 3 times the second fraction. And then I've got x minus 3, x plus 3 times the third. I like to write it once for every fraction. That way I'm remembering what cancels. It helps me process this instead of just writing it once off on the side. Okay, I'm just giving you a moment to get caught up because I know there's a lot of little writing detail there. Once we clear the fractions, this is not going to be a big deal to solve. This is the big deal step right here, is finding the common denominator and clearing the fractions. And then once we solve this, I've got one detail that I have to remind you of from the beginning of the chapter. All right, so the first fraction, I've got 2 over x minus 3 times my common denominator. I think we would all say that it looks like that x minus 3 is going to cancel. And when I do that, and I distribute, what do I have left over? Yeah, perfect. Thank you very much. 2x plus 6. Lovely. The second one, I've got the x plus 3s that cancel. Now, I'm just going to give you a little heads up. Don't forget that there's a minus there. So this is a minus 3. When I distribute that minus 3, what do my next terms become? Negative what x? Yeah, negative 3x. You probably said it. My hearing's just not great. Negative 3 times negative 3 is plus 9. So negative 3x plus 9. And then that equals, and on the other side, it's a canceling party. The plus 3s cancel, the minus 3s cancel, and I'm just left with 12. The problem you do right next door is going to work just the exact same way so that you get the tactile learning of writing everything. But let's finish this one up. I've got 2x minus 3x, that's negative 1x, or just negative x. 6 plus 9 is 15. I'm going to subtract the 15 from both sides. And I get negative x is equal to negative 3 is what my calculator would tell me. And then last but not least, I'm going to divide both sides by negative 1, and I get x is positive 3. Now, don't write that in a solution set just yet. I'm going to pause. I'm going to let you catch up. Just ran through the steps there because we solved about 1,000 linear equations in this class. So hopefully that is familiar territory to you. But now we have to talk about something. What I'm about to tell you did not happen on the front page. That's why I didn't address it. I want to just do one detail at a time on solving these equations. But there's one thing you always have to be aware of when you're dealing with fractions. It was the very first thing we talked about in section 1. And that is, what value can I never have in the denominator of a fraction? 0. Okay. So when you solve a rational equation, you always have to make sure that this answer here doesn't accidentally make one of your denominators 0. Okay, so I'm just going to make a little note for you. Always check your values with the denominators. Sometimes they're going to make a denominator 0 and you're just going to throw it out. It's no good to you. Sometimes it's not going to make a denominator 0 and it's going to be a perfectly wonderful solution. Okay, so when I check this 3 in the denominator, what happens in my first denominator? Right here? Yeah, what's 3 minus 3? 0. Yeah, it cancels out. The second one, 3 plus 3 is 6. Doesn't affect that one. All it has to do is fail once. So when I plug this 3 back up in this denominator, I get 3 minus 3. That is 0. So unfortunately, what that means is I've got to discard this solution because it makes the denominator 0. I have no other solutions to check. So my answer for this problem is going to be the empty set. So I'm going to just write here below this, I'm going to write that the solution is the empty set. There's no solution to this problem. The only value that could possibly work made one of the denominators 0. So unfortunately, there's nothing left. So we're going to practice that detail as well as practice solving these rational equations. Okay, so go ahead, exercise 6. Exercise 6 works exactly like the one we just did. So go ahead, factor that denominator, find your common denominator, and do that problem. If you need me for anything, raise your hand. I'll come to you. We'll look at it together. So factored the last denominator, t squared minus 49. It's a difference of squares. Okay, for the next problem, there's another difference of squares just because they go a little swiftly when you're factoring. So we got t plus 7, t minus 7. So my common denominator, one of every factor, is t plus 7, t minus 7, or t minus 7, t plus 7. The order is unimportant. So I'm going to take that, hopefully like you did. And if you didn't, hopefully you'll ask me a question. And I'm writing it next to each fraction one time. Now we're going to cancel those denominators, because that's the whole point to this process, is I don't want to deal with the fractions. So the t minus 7s go away in the first one, and I have 1 times t plus 7, which is just t plus 7. And then the t plus 7s go away in the second one, and then I have 2 times t minus 7, so that's 2t minus 14. And then on the next one, everything goes away. So there's no more denominator, it's just the value 14. That's a super difficult thing. Practice that. Okay, getting rid of fractions, clearing the fractions is a good skill for you to have as you press forward in your math career. Okay, t plus 2t is 3t. 7 minus 14 is negative 7. I'm going to add that 7 to both sides. This is pretty standard linear equation. I'm going to divide by 3, and I get t is 7. Okay, if you did that, you've done 100% great. But before we get all excited and throw that into a solution set, got to make sure that it doesn't make any of the denominators 0. Does this value here affect any of my denominators? Yes, the first one. 7 minus 7 is 0. So unfortunately, while 7 is the solution to the linear equation, the 7 is not the solution to the original equation. So I throw that away, I cry a little bit, and then I go ahead and my solution is the empty set. Now that doesn't happen every time, but I just thought since I just showed you one, it would be good to reinforce it with the next one. In fact, on the next problem, it's not going to happen so that you can see the difference. So exercise 7 functions in pretty much the same way. Factor the one denominator that will factor, come up with your common denominator, and then from there, press forward. Okay, so the middle fraction, I can factor x squared minus 4 becomes x plus 2, x minus 2. It's another difference of squares. So that means my common denominator, one of every factor I see, is x minus 2 times x plus 2. So I'm going to now take a different color pen. I'm going to write that for each of these fractions. So I've got x minus 2, x plus 2 for the first fraction. I've got x minus 2, x plus 2 for the second one, and then x minus 2, x plus 2 for the third. So now we can get rid of fractions, and this will be great. So the first one, the x minus 2's cancel. When I distribute, we've got 3x plus 6. The second one, both things cancel. The x plus 2's cancel and the x minus 2's. So I just have 21. Okay, I like when everything cancels, less work to do. And then the x plus 2's cancel on the last one. And so I have 14 times x minus 2. That's 14x minus 28. From here, I'm going to collect those like terms. 6 plus 21, that is going to be 27. And then on the other side, I've got 14x minus 28. I'm going to put all of my x's on one side. I'm going to put all of my numbers on the other side. So I'm going to subtract the 14x to get all those on the left. So 3x minus 14x, my calculator tells me that's negative 11. I'm going to subtract the 27. Negative 28 and negative 27, that is negative 55. And when I divide by negative 11, x is equal to 5. So let's just make sure we've gone through all the work. Let's make sure we are 100% accurate in our answer. Does 5 make any of the denominators 0? Well, 5 makes the first denominator. 5 minus 2, that's 3. Okay. 5 makes the second denominator. 5 squared is 25 minus 4, that's 21. Okay. And then the third denominator, 5 plus 2 is 7. Perfect. None of them are 0. So that is a perfectly wonderful solution. I'm going to put it right there. All right, we got 3 more problems. They all function in the same way, just more practice. Exercise 8, here's what we're going to do. We're going to take this one in phases because the denominators are a little bit more complicated, but you'll be able to run through it the same way. What I want you to do is this. I want you to factor each of the 3 denominators, and then I want you to propose the common denominator. Okay, what do you get when you take one of every factor? So I'm going to give you a couple of minutes to do that. It's factoring and then determining the denominator, and then you can pause. Okay, so going through the factoring here, x squared minus 2x minus 8, when I unfoil that, the two factors of -8 that are going to add up to -2 are -4 and +2. So I have x minus 4, I have x plus 2. The second one, the two factors of 8, when I unfoil that add up to 6, are 4 and 2. So my two factors are x plus 4, x plus 2. The third one's a difference of squares. So that's going to be x plus 4, x minus 4. So when all is said and done, what are the factors that I need for my common denominator? Well said. X minus 4, x plus 4, x plus 2. So I know that's a long train of factors, but this is going to work out okay. Okay, so trust me just for a second here. So what I'm going to do, and so that you can write it down as well, and then I'm going to let you finish the problem, is I'm going to write that common denominator once for each fraction. And then when we cancel, all these fractions should go away, and what's left should be entirely reasonable to solve. So the first one, I've got x plus 4, x minus 4, and then x plus 2. Oops. And then the next one, I've got x minus 4, x plus 4, x plus 2. And then the last one, x minus 4, x plus 4, x plus 2. And there's my common denominator. Now all you have to do is go and cancel and solve the equation that appears. All right, so I'm gonna get started with the busy work. If you're still doing the busy work, keep doing it. Okay, we'll all meet up at the end. The first fraction, the x minus 4s and the x plus 2s cancel. So I have 2 times the x plus 4, so that's 2x plus 8. The second fraction, the x plus 4s and the x plus 2s cancel. So I have minus 4, don't forget that minus. I have minus 4 times x minus 4, so that's minus 4x plus 16. Then on the other side, the x minus 4s and the x plus 4s cancel, and I have 2 times x plus 2, so 2x plus 4. So all is said and done, we end up with a fairly tame linear equation. 2x minus 4x is negative 2x. 8 plus 16 is plus 24. I'm going to put all of my x's on one side, all of my numbers on the other, so that I'll be just about done. So I'm going to subtract the 2x. I like to get all my x's on the left. That is not required. It's just my habit. So I have negative 4x. And then I'm going to bring the 24 over. 4 minus 24 is negative 20. And then minus 4, or divide by minus 4, and we get x is equal to positive 5. Here's a little hint for you when you go to plug that number back in to see if it makes a 0 in any of your denominators. You don't have to plug it back in the original quadratic. That takes too long. Just look at the individual factors. So you've got 5 minus 4, that's not 0. You've got 5 plus 2, that's not 0. 5 plus 4, that's 9, that's not 0. 5 plus 2 is 7, that's not 0. 5 minus 4 is 1. 5 plus 4 is 9. It doesn't make any of these things in the denominator 0, so we are good to go. 5 is my answer. We got 2 more problems to go. We're going to do them out of order because exercise 10 is functionally just about identical to what we just did. It gives you another chance to run through the process. So I would like you, we're going to exercise 10. For exercise 10, go ahead and determine what the common denominator is. And once you've done that, you can move on. I'm going to give you about 2 minutes. I'm going to help with the common denominator, and then I'll give you about 2 minutes more after that to finish the problem out. All right, so the first thing to do is a little bit of factoring here. The two factors of -6 that are going to add up to +1 are +3 and -2. So there's my first two factors. The second equation, or excuse me, the second fraction, the two factors of -2 that add up to -1 are -2 + 1. And then finally, in the third fraction, the two factors of 3 that add up to 4 are 3 and 1. And so hopefully, if you were looking at that, or you're looking at it now, you see that when I find my common denominator, one of every factor is going to be y plus 3, and then y minus 2, and then y plus 1. That's one of everything. There's no powers, so I don't need anything greater than that. So now use that and clear your fractions. Give you another minute or two, or more like 2, to clear the fractions and solve the equation that results. All right, so going through this, canceling what I can. So the first fraction, the y plus 3's cancel, the y minus 2's cancel. I have 2 times y plus 1, so that's 2y plus 2. There's my first set of terms. The second fraction, the y minus 2's cancel, the y plus 1's cancel, and I have 1 times y plus 3 is just y plus 3. And then the other fraction, the y plus 3's cancel, the y plus 1's cancel, and I have 4y minus 8. That's the hard part to this problem. That's definitely difficult. You won't convince me otherwise, but the rest of this is familiar to us. 2y plus y is 3y. 2 plus 3 is 5. Subtract the 4y from both sides. 3 minus 4y is negative 1y, or just negative y. When I subtract the 5, negative 8 and negative 5 is negative 13, and divide by negative 1, and y is 13. When you take the y as 13, you check it with each of the factors. It does not make any of these factors equal to 0, so there's nothing to, you don't have to toss out that solution, so we're going to keep it. There's 13. One more problem, and you're done with me for another week of this class. So we're getting really close to the end of the semester, believe it or not. Okay, exercise 9. First thing I want you to do, there's nothing to factor on this one. So real quick, write down on your paper, what is the common denominator? I'm going to give you 20 seconds to do that. Nothing to factor there. What is the common denominator? And what factors do you need here in your common denominator? An x minus 2? And what else? An x. Remember, this x minus 2 is a completely different value than just the plain old x. So you need to include both. Okay, take that, clear your fractions, and just to give you a little heads up, this last problem, you're going to end up with a quadratic that has a number that's not 1 in front of the squared. Okay, so you're going to have to revisit factoring that. Okay, if you've completely forgotten, we'll go through it in just a minute. Do as much as you can. All right, here we go. We're going to wrap this section up. So let's go ahead and clear these fractions. So the first one, the x minus 2's cancel. And I have 2x times x, so 2x squared is my first term. The second one, the x's cancel, so I have negative 3 times x minus 2, so that's negative 3x plus 6. And then the last one, the x minus 2's cancel, and I have 4 times x is 4x. I'm going to collect those like terms to make this a little bit nicer to look at. So negative 3x plus 4x is x. So it's a quadratic. It has to be equal to 0. You have no choice about that. So I'm going to bring everything over to the left. I'm going to subtract the x. I'm going to subtract the 6. And here is what we get that we have to solve at this point. So I have 2x squared. I have minus x. Minus 6 equals 0. I have a quadratic that has a number that is not 1 in front of the x squared. So the way that I showed you in this class to do this was by the grouping method. So what I'm going to do is just run through that. The grouping method, remember, says take this first number 2 times this last number negative 6. 2 times negative 6 is negative 12. And I need the two factors of negative 12 that are going to add up to negative 1. And that's going to be negative 4 and positive 3. I use those two factors to separate this middle term into two terms. So 2x squared minus 4x plus 3x minus 6. Notice this thing that has 4 terms is exactly the same thing as the one right above it. It's just not simplified now. I'm going to factor this by grouping. Out of the first 2 terms, 2x squared and 4x, I can take a 2x out. 2x squared, I factor out 2x, leaves x. Negative 4x, when I divide by 2, negative 4 divided by 2 is negative 2. The second pair of terms, the 3x and the 6, I can take out a 3. 3x, factor out the 3, leaves x. Negative 6, factor out the 3 is negative 2. And then finally, at long last, I have my 2 factors. The first factor is x minus 2, because it's what it has in common. And the second one, I have a 2x from the first term and a plus 3 from the second. So my 2 factors, I've got x minus 2 equals 0. I've got 2x plus 3 equals 0. X minus 2 equals 0. When I add 2, I get that x equals 2. The second one, I'm going to subtract 3 first. And when I divide both sides by 2, I get negative 3/2. So I've got 2 solutions. I've got to check them both. And something interesting, or at least to me, happens when I check the 2. First fraction, 2 minus 2, that is 0. Oh, bummer. I gotta throw that one away. That makes the denominator 0. Negative 1.5. Well, negative 1.5 doesn't make either of these denominators 0, so that answer is just fine. So my solution set just has one thing in it, and that is the negative 3/2, because I had to throw the 2 out because it made the denominator 0.